Okay, so 312, the classwork we're going to do. So I got a little Jamboard here. Hopefully you have your books, or you could just look at the Jamboard here. Actually, hold on a second while I'm recording. Here we go. Okay, so we're starting off with 24 here. Okay, how can I use a graph to solve the equation? Kind of continuing the last lesson from last time, but we're going to go more in depth. Okay, so let me get my pen. 24. All right, 3-1. In problem number 1 of this section, we use a graph to solve the equation. And what other ways can a graph be a useful solution tool? Consider this question as you solve the equation square root of 2x plus 3 equals x by completing A through D here. So for part A, use algebraic strategies to solve the square root of 2x plus 3 equals x. How many solutions did you come up with? Which strategies did you use? So for part A, let's go ahead and copy down the problem and solve this algebraically. Square root of, you know what, I'm going to move this section up so I just have more room to work with. Okay, I can move that up now. And yeah, that'll be better. Okay, so get my pen back. So I'm going to copy up here. A, square root of 2x plus 3 equals x. So I want to solve for x, right? What should we do, guys? First step to like get rid of the square root, maybe. What should we do? Let's try squaring the problem, right? The opposite of the square root is taking the square root is squaring something. So we're going to square that side and we're going to square this side. We're going to square both sides of the equation. I think this is the first time we've done this in Algebra 2. We might have done it in Algebra 1 a little bit, Math 1. So when you square the square root, that's just going to get rid of the square root, right? So we're just going to have 2x plus 3 equals x squared. Okay. All right, now, now we have a quadratic because we squared it, so we got to get this equal to 0. So let's go ahead and minus the 2x from both sides, minus 2x, and minus the 3 over here, and minus the 3 over here. Okay, so 0 is equal to this trinomial x squared minus 2x minus 3. Very basic quadratic trinomial, so usually we factor to solve the trinomial. So if I factor this, x squared factors down to x times x, 3 factors down to 1 times 3, and we got a -2, so the 3 will be negative and the 1 will be positive. Okay, need to move my bar out of the way here. Okay, and then we set them equal to 0, use the zero product property. X plus, sorry, my pen is going all over the place. X plus 1 equals 0, and x minus 3 equals 0. So x equals -1, and x equals 3. We get 2 solutions, right? It's a quadratic, we get 2 solutions. We've been doing quadratics forever, so hopefully you know how to factor and solve a quadratic. It's very basic. It's a basic skill you need for Algebra 2 and pre-calc and calculus. Okay, so how many solutions we came up with? We came up with 2 solutions, right? That's what A asked for. We have 2 solutions because this is a parabola, and those 2 solutions are actually, usually find the x-intercepts, but actually this is where these 2 graphs intersect. Okay, part B here. In thinking about the square root of 2x plus 3 equals x, Miranda writes down y equals the square root of 2x plus 3 and y equals x. How many solutions does y equals the square root of 2x plus 3 have? How many solutions does y equals x have? Okay, so part B here, remember, square root equations, this graph is going to start at -3/2. So like here's -2, here's -1. So it's going to start around here, and it's a square root problem. So how many solutions does the square root problem have? We talked about this last time, guys. Go ahead and unmute yourself. How many solutions does this equation have? Is anybody paying attention out there? Or just
2.
a bunch? 2. Okay. Anybody else?
1.
1 solution?
Infinite.
It has an infinite amount of solutions. Y equals the square root of 2x plus 3 has an infinite amount of solutions, because how many points are on this graph, you guys? Many points.
Infinite.
Right, an infinite. There are many points on this graph. Here's a bunch. 1, 2, 3, 4, 5, 6, 7. And then since the graph goes on forever, I could keep making points on this graph. So there are many points. There are an infinite amount of points on this equation. So there are an infinite amount of solutions. Okay, so for y equals x, same question. How many solutions for this graph y equals x?
Infinite.
Right, they're infinite points. They're infinite solutions, points/solutions. So you're writing this down, right? Everybody's writing this down. So when you turn this in, I see all this work that I'm doing, you're copying down. This is your notes for today and the classwork for today. So we have infinite amount of solutions, infinite amount of solutions. That's the answer to B. C. Miranda says, I'll graph both the functions y equals the square root of 2x plus 3 and y equals x to check the solution from part A. How will graphing help her determine the solution? Okay, so let's graph both of these on either a graphing calculator. Your book will have graphing calculator pictures. If you have a graphing calculator, go ahead and do it on your graphing calculator. Press the y equals button. There's a y equals button. And you have to go on the graphing screen. I should have printed the Jamboard from yesterday where I had the calculators up there. You can totally use your graphing calculator to do this. But since we're on a computer and we're Zooming, I'm going to do this on Desmos. I need to clear the screen here. So let me clear that. And let's go to Desmos. So I've typed in the equations here. I typed in y equals square root 2x plus 3. So here's that graph, the red one. And then y equals x is the 45-degree angle line. All right. How many times do these two lines intersect, you guys?
Once.
That's right, once, right? And let's see where it intersects. Let's click on it. Oh, it intersects at 3, 3. Should you write this down? Absolutely. Draw a quick sketch of this, please, on your paper. And I'm going to write 3, 3. But we got 2 answers. So one of the answers is x equals 3, right? Where the 2 lines intersect, that's your answer, okay? So x equals 3 is one of the answers. And the other answer we got was, can you guys double check this? Was it x equals -1? Yeah. But this graph only intersects once. So, but if this continued, you know, if I continued this graph, it would go like this. Go down, sorry, I'm not graphing too well, but it's right here. It would intersect at -1, -1. But since the graph doesn't have a negative portion because it's a square root, it is only the positive portion. One of the answers we got doesn't work. It doesn't actually intersect there, okay? So that part doesn't intersect because the graph doesn't go on. So we have what we call an extraneous solution. So the x equals -1 is an extra. Extraneous is long for extra. It's an extra solution. Okay, so let's write this word down. Extraneous solution. It's an extra solution that actually doesn't work. This is why it's important to go and check your work. Okay, we checked our work by graphing the 2 equations and seeing where they intersect, and they only intersect once. They didn't intersect twice. Okay, but we're not always going to use Desmos, right? You're not allowed to use Desmos on tests, and when you get to the regular classroom, you're definitely not going to be able to cheat and use Desmos on a test or a quiz or anything like that, all right? So you have to be able to do this algebraically or with a graphing calculator if allowed. So what we need to do is write that this is an extraneous solution. So I'm going to clear this and go back to our Jamboard. Okay, so let's answer part C. How will graphing her? So graphing it, part C, basically showed us that by graphing, we saw that one of the solutions was not actually a solution. Okay, we see that x equals -1 is not a solution. It's extraneous. Okay, we saw that by the graph. Okay, is there a way to do it without graphing? Okay, we're not always going to use Desmos, and so yeah, there is going to be a way. So part D, Miranda looks at the graph on her graphing calculator and says, I think something is wrong. I only get one intersection, right? So that's true. So let's plug in into the equation. So this is part D. The square root of 2x plus 3 equals x, where we've set the two equations equal to each other, right? Since they're both equal to y, we use equal values. We set them equal to each other. Let's plug in -1 and see what happens. So when I go the square root of 2 times -1 plus 3 equals -1, this is going to be the problem here. When you take the square root, can you have a negative? Right? Only if you're dealing with imaginary numbers. So the square root of, 2 times -1 is -2 plus 3, which is going to be 1, and the square root of 1 is 1. It's not -1, right? You can't have a square root be negative. So this is false, right? So when we plug it in, it doesn't work. That's how you know you have an extraneous solution, because you have to check your solutions. You have to check your two solutions. You have to plug each one of them in. When we plug in x equals 3, it is going to work, right? It's not going to be -1. It's going to be positive. So, but the extraneous one won't work. Okay, and we talked a little bit about this last class period, but we didn't have a problem to show you. Now we do. We have an example to show you how to check. All right. So that's how you check for extraneous solutions. So let's go on to 25 here. Got to clear this out. All right, 25. What does this say? This says, when a result from a correctly solved equation does not make the original equation true, this is called an extraneous solution. Okay, so it is not a solution in the equation, even though it is a result when we solve it algebraically. So we got two answers. We got x equals 3 and x equals -1. How do you know which one is extraneous? You have to plug both of these back into the equation and check them. And then that's the only way you're going to know, hey, that one's not a solution. Okay, why did that happen? Why do we have extraneous solutions? Because we ended up squaring. Remember how we had this 2x minus 3? Remember how we squared the equation? Well, when you square equations, you create extra solutions that shouldn't be there. And that's why, because when you square something, you've created two solutions, right? So this, we've created an extra solution when we square both sides. So that happens when you square both sides of the equation. So it's very important that you check your solutions. Even if the directions don't say to check them, you have to check them when you square both sides and just when you solve any problem in this chapter. Okay, so that is 25. 26, the fact that the extraneous solutions can arise after solving correctly makes checking your solutions very important. You have to check your solutions in this chapter, okay? You have to. Before it was an option like, oh, if you want to check it, you can check it. And rarely does anybody check it unless you're taking a test. But in this chapter, you have to check your solutions, okay? But why does the extraneous solution appear in this problem? Examine this graph and examine that graph. Where would this x equals -1 happen? So let's just draw the sketch of the graph. What happened in the graph? We had the -2 was over here, and it was -1 point something. -3, 1.5 is where it starts. And so we graphed the square root equation, this part, and then when we graphed, they don't have squares on them, right? We graphed the square root part. When we graphed the x, how many times did they intersect? Only one intersection. Okay, only one intersection. So, but we got two answers, right? So we know that one of the answers wasn't wrong. And like we said, if we continue this graph, we'd get another answer, but the graph doesn't go down there. So there was only one intersection. That's why we had an extraneous solution. Okay. And we kind of answered that already, but we'll write it down for 26 there. I'm going to clear this out. Now I have to edit my video and take that part out. That's annoying. All right. 27 is this. What are we doing? Get my pen back. Let's change colors to blue. After solving the equation 2x squared plus 5x minus 3 equals x squared plus 4x plus 3, Gustav gets called to the office and leaves his team. Oh, Gustav, he got called to the office. So this is our new equation. When his teammates examine his graphing calculator to figure out how he found his solution, they only see this equation, y equals x squared plus x minus 6, which is totally different from this equation. Well, kind of different. Consider this situation as you complete the parts below. Solve this algebraically. And then where did Gustav get this equation from? Okay, so let's write down our original equation A. Says 2x squared plus 5x minus 3 equals x squared plus 4x plus 3. We want to solve for x. What do we do first?
Could you subtract the 4x to both sides?
Okay, so we're going to subtract basically the right side over to the left side, right? So I'm going to subtract x squared here, subtract x squared. And let's go ahead and subtract all of it. Let's go ahead and subtract the 4x over here and bring it over here to the 5x. And let's subtract the 3 and bring the 3 over here so that we can get 0 over here, right? We want one side to be 0. So 2x squared minus x squared, that's x squared. 5x minus 4x is x. Minus 3 is minus 6. Okay. And let me make sure that's correct. I feel like I got something else. This is problem 27. Okay. All right, that should be correct. And then we factor this. So the x squared factors down to x times x. The 6 factors down to 2 times 3. It differs by 1. We need to get a positive 1. So we need a positive 3 and a negative 2 there. And solve this and we get x equals 2 and x equals negative 3. So we got 2 solutions. Now we need to check what about these solutions, you guys?
See if they're extraneous.
Right, we have to see if they're... Right, so we have to see if they're extraneous. Let's see if we get to that. Let's see, solve this algebraically. So that's part A. Where does Gustav get this equation from? So this is the equation he got. Where did he get this from? Do we see this in our problem somewhere?
No.
Look closely.
Oh my gosh, I didn't even see that.
So how did he get that equation?
He just made 0 be y instead of 0.
Okay, so we brought everything from the right-hand side over to the left-hand side, right? We basically subtracted this equation to over here and basically combined the 2 equations. So we subtracted this one from that one and we got, so let's call him Gus. Gus subtracted the equation, subtracted the right side, right? Right side equation over to the left side. And then you're right, and then he made the y and he let the 0 part equal y, right? So we got 0 and then he just put a y there. And that was his equation. Okay, and this, if we graph it, this should be a parabola, right? This equation right here should be a parabola, which we should get like 2 solutions on a parabola. Okay, but I'm jumping ahead. So C, how many solutions will, oh, there we go. Well, actually, how many, I don't know what question, how many solutions does this actually have? Does it have 2 or more? from our discussion earlier, how many solutions does this have?
Infinite.
Infinite.
Right, so y equals x squared plus x minus 6 has infinite solutions because there's infinite amount of points. So that kind of doesn't help us because, you know, we want to narrow down the solutions. How can you see the solutions 2x squared plus 5x minus 3 equals x squared plus 4x plus 3 in the graph of this? Do you think that it would be the x-intercepts? Let's just put, maybe it's the x-intercepts. Yeah, it should be the x-intercepts, right? Definitely. Because, why should it be the x-intercepts? Because we had it set equal to 0, right? And so your zeros are your x-intercepts. So this tells me, oops, I shouldn't draw the y over here. The y is over here. The y-axis is over here because our solutions are x equals 2 and x equals 3.
I think it's actually -3.
Is it -3? Yeah, one of them's negative. Thank you. So I did draw it right. So this is x equals -3 over here, and the x equals 2. Okay. So those are two solutions, -3 and +2. So yes, throw a negative on there to make that solution. Okay, let's look at E here. I need to move E up. I purposefully put it at the bottom. So I'm going to erase some of my writing here. And I'm going to move E up after I get rid of this. And I don't need this, so I'm going to move that out of the way. Move E, some movie magic here. Maya solves 2x squared plus 5x minus 3 equals x squared plus 4x plus 3 by graphing a system of equations and looking for the points of intersection. What equations do you think she uses? Graph these equations on your graphing calculator and explain your solutions. So if I graph this, I should get a, what? I didn't type these in my, what's it called? I didn't type this in Desmos, and I should have, I don't know. This is going to be something like, I don't know, parabola like this, right? I should get some parabola going up. And then this other, the right side should also be a parabola. So how many, I don't know, how many solutions are we going to have? It depends where the parabolas are. You had a problem like this on the very first homework assignment at the end of the first homework, because I was grading it and some people didn't draw pictures, and I was kind of annoyed that people didn't draw pictures. It asked you how many ways can two things, a circle and a parabola, intersect, right? Something like that. So you could have one intersection or you could have two intersections. We should check both of these and we should plug them in, but I know we still have like 3 more problems to do, so I'm going to move on. Technically, you should plug these in. I don't know. I'll check the answer later. Maybe one of these might be extraneous. I'll check later, or you can check in your book. Your book will tell you. Okay, but I'm going to move on. You get the gist of it. Okay, 28. Yahaira cannot figure out how to solve 20x plus 1 equals 3 to the x power algebraically. So she decides to use her graphing calculator. However, when she graphs the two equations, y equals the left side and y equals the right side, this is what she gets. So she says, hey, there's no solutions because they don't intersect. Is that true? Is there no intersection for these two graphs?
I don't think that's true.
Why not? I think you're right, Mateo. Tell me why not.
I think on the one's exponential, right? Or am I seeing something?
Right, yes, one's exponential. This one, right?
Yeah, so it's gonna eventually collide.
So eventually they're gonna intersect, right? So this is going like this, and then this is a line going like that. So they have to intersect somewhere, right? At some xy. So yeah, you're absolutely correct. They're gonna accept, they're going to intersect here. What about over here?
Yeah, it looks like it.
Yeah, if it's a curve, eventually they're going to intersect somewhere, right? So Yahaira is correct. If she's only looking at this window, they don't intersect. But if we think larger than just a calculator window, they're going to intersect twice. So let's put for 28A, the line and curve will intersect twice, just because you can't see it. And what she needs to do is change her window. And you can do that on your graphing calculator. There's a window button way at the top. It's like a second function. And it automatically defaults to -10, from -10 to +10. Well, you can change that to -50 if you want, to +50 if you want to, if you need to. You can change the window to whatever you want. So if you have your graphing calculator, change the window and play with it so that you can actually get an intersection point, okay? Part B, what should solutions to the equation 20x plus 1 equals 3 to the x look like? In other words, will solutions be a single number, or will they be coordinates of a point? Should we get a number or coordinates, guys? Well, we're going to get one x. Let's call this x1, right? We're going to get some solution for this one, x1 right here. And I'll call this x2, right? So are we just going to get an x1 and x2? Or are we going to get a x1, y1 and x2, y2? That's what they're asking us. Is the solution going to be just an x, or is it going to be an x and a y?
X and a y.
Yeah, well, if we do the graph, right? So if for the graph, we're going to get an x and a y if we do the graph. But if we just solve this algebraically, is there even a y in this equation? No, there's no way we can get a y for just the equation. So if we just do it algebraically, if we just use the equation, we're just going to get x equals something, right? x1 equals something and x2 equals something. We're not going to get a y. But if you actually do the graph, you can get an x and a y, right? And you can only get an x and a y if you use the graph. So most of the time we're going to use algebra, but if you're allowed to use a graphing calculator, then you can get a graph. But usually we're just going to look for these two answers right here, just an x, okay? Okay, so part C, Yahira's teammate Emma starts to solve by subtracting 1 from both sides. She subtracts 1 from here, subtracts 1 from here. When she graphs her system later, she uses y equals 20x and y equals 3x minus 1, 3 to the x minus 1. Will she get the same solutions? Test your conclusion by using your graphing calculator. Okay, so she decides to subtract 1, right? Emma decides to subtract 1, so her equation is a little different now. Now it's just 20x instead of 20x minus 1. Instead of just 3 to the x, she has 3 to the x minus 1. So is that going to change where the two things intersect? What do you think? We're on C. I'm going to erase this and go to Desmos. So let's go to Desmos and let's put these in the graphing calculator. I'm going to erase this. I'm going to change this. Our equations are what? Y equals 20x plus 1 was the first equation. 20x plus 1, which is just a line. Okay. My second equation is y equals 3 to the x power. 3 shift 6x power. Okay. So I can only see one intersection at 0, 1 right now, right? But if I like zoom out, can I zoom out? A lot. I could see a second solution up here, right? It's, 481. So we have two solutions, 0, 1 and 481. Those are our 2 points. So let's go ahead and write that. Go ahead and write that on your paper, 0, 1 and 481. Those are our two solutions. Okay, let's put her teammate's equations on here. Her teammate's equation was y equals 20x and y equals 3 to the x, 3 to the x minus 1. I have to scoot over to the right and do minus 1. Okay, are they going to get the same solutions? And this is so big that you can't really see. I'm gonna take these other ones. I'm gonna like not graph them. Okay, and let's see what our solutions are. I'm gonna zoom, zoom, zoom in. Oh, look, is it still 0, 1 where they intersect? No, they now intersect at 0, 0 for her teammate solution. And the other one is going to be, zoom out again. See how the window is really big and you have to change the window to much bigger. So I would have to change my graphing calculator window to like set to like 80 to see where they intersect. 480. So what happened to the Y? It's almost the same as Yahaira's, but it just went down 1, right? The other one was 81, this is 80. The other one was 0, 1, this is 0, 0. So the solution differed by 1, it went down 1, okay? So that's what you need to write for part D there, right? Or no, part C. Part D, discuss with your team why Yahaira cannot solve the system algebraically. Okay, how come we can't? We had to use Desmos to solve this one. If you didn't know this, we'd never solved it algebraically. Why can't we solve 20x plus 1 equals 3 to the x power? What is different about this equation, guys, than the last 2 or 3 that we did? Like the only thing you can do is minus 1, right? And you get 20x equals 3 to the x minus 1. But what's happening here? The x is it's an exponent. You do not know how to solve equations yet where the x is an exponent. Okay, you don't know how, you don't have enough math knowledge to do that. But we're going to learn how to do that this semester. Okay, it's called logarithms. You're going to learn how to solve using logs, and you have to use logs to solve this, but you don't know what a logarithm is yet, and we are going to learn that second semester. Okay, so that's why we don't know how to solve this algebraically, because we don't know about logs. Okay, I need to erase this and go on, I think, to the last question. Let's see. Yeah, last slide, 29. Jack was working on solving an equation, and he graphed the functions f of x equals 12 over x and g of x equals negative x minus 3 squared plus 4, as shown at the right. So 12 over x is going to be your hyperbola, where you get curve, curve. And then this is a parabola pointing down because it's negative, so that's that parabola right there. What equation was Jack solving? So what do we have to write on our paper to solve this, you guys? So 29a, we have to set these equal to each other, right? This is like y equals 12 over x, and this is y equals this. So we have to set them equal to each other. So 12 over x equals negative x minus 3 squared plus 4. That's how we set it up. We set them the two equations equal to each other, and we solve it for x. The y's are now gone. So that's part A. Use points A and B to solve this, because if you try to solve this algebraically, you get an x to the third equation, and right now you guys don't know how to solve that. Okay, so because I tried working out yesterday by multiplying by x here, multiplying by x here, the whole thing, and it's pretty messy, and you get an x to the third equation, and you guys don't know how to do that. So we're not going to do that. So I'm going to undo all that I did right there. So it says to use the graph. So from the graph, we can see where do these two graphs intersect? Where does parabola and that intersect? At x equals 3, right? At x equals 3 and x equals 4. Those are the solutions according to our graph. If we were to graph this in our graphing calculator, we would get x equals 3 and x equals 4. Okay, so that is our answer to part B, right? But it says use this to solve our equation. So we need to plug these in. Are these solutions? So we need to plug these into the equation. So let's go ahead and plug them in. Let's plug in 3. 12 over 3 equals negative 3 minus 3 squared plus 4. 12 divided by 3 is 4. 3 minus 3 is 0, so we get negative 0 squared, which is just 0, plus 4. So 0 plus 4 is 4. We get 4 equals 4. So this is a solution, not extraneous, right? It should be a solution because it's on the graph. So now let's check x equals 4 by plugging it into here. 12 divided by 4 equals negative 4 minus 3 squared plus 4. Okay, so 12 divided by 4 is 3. 4 minus 3, that's 1 squared times negative 1 plus 4. Well, you do the squared first. So 1 squared is positive 1 times negative. That gives you a negative 1. Order of operations, super important right there. That's a negative 1, not positive 1. Okay, 4 minus 1 is 3, so we get 3 equals 3. Check, this is an answer. So these are our two answers according to this graph right here. Okay, but lastly, part C, are there any other solutions to the equation in part A? If so, show that these other solutions make your equation true. Well, what's happening down here? Let's see, we get continue, continue, continue. This continues, continues, continues. And it goes this way. So what's going to happen over here? And I did this on Desmos yesterday, and I got x equals negative 1. So there's actually one more solution that you can't see. So let's try x equals negative 1 in our equation. So 12 divided by negative 1 equals negative 1 minus 3 squared plus 4. Okay. 12 divided by negative 1 is negative 12. And we do the negative 1 minus 3 first, which is negative 4 squared times negative 1 plus 4. Negative 4 squared is 16 times negative 1 is negative 16 plus 4. So that gives me negative 12 equals negative 12. So indeed, there is actually one more solution. So this problem has 3 solutions, right? Not just 2. We only saw 2 because the graph wasn't big enough. The window wasn't big enough. But we know if this is a curve and that's a curve, they're going to intersect one more time. So there's actually 3 solutions. X equals 3, x equals 4, and x equals negative 1. All right, guys, so this is how you find solutions. You sometimes you have to use the graph to help you out sometimes, and you also have to use the algebra to solve some of the problems you can solve, and some of them you have to use a graph. All right, so that is the classwork that you need to turn in to right here. Assignment 3 classwork, you're going to submit it. There's 32 of you. Hopefully I get at least 30 assignments. You're going to turn that in right there. And then your homework is this stuff. I will be posting something tomorrow to check in because tomorrow's Wednesday and you have to do some kind of activity on Wednesday and hopefully work on this homework tomorrow because it's due Friday. So make sure you check in on Wednesday. If you have any questions, I have office hours today from 2 to 3 and you're welcome to join those as well. All right, so that is the end.